क्या साहब?
2 घंटे के लिए आया था।
आवाज क्यों नहीं आ रही इसकी?
Good evening, all of you.
Good evening, sir.
It's the 2 hours of class today, 5 to 7. All of you are comfortable.
Yes, sir.
Okay. And so many students that are having that some queries yesterday regarding that is PDF and all the things, means slides, notes, and all the things. I will just confirm one thing that that once the unit will be over, so you will be shared with all the slides. So then for your reference. Okay. That's fine. Okay. So now the thing is that yesterday we have completed till the what is? Can you say that till what we have completed yesterday? Emission spectroscopy was over, right? Can you hear me?
Yes, sir.
Okay. So yesterday up to emission spectroscopy you have covered. Hope that you have gone through your syllabus which is provided by the IGNOU.
Hey,
So by your
uh,
hello. Is there any issues, Mr. Somen? Okay, so we have yesterday last class we have finished with the emission spectrometry. So today we'll start with the absorption spectrometry. So hope that actually you people have to take the screenshot which is showing in your. I just shared that slide. So you just check it out. If you take the screenshot, that will fine. So later on, after the completion of this unit, I'll provide you all the slides through the sharing with your email ID, or else the chat box. So that is, I just got the confirmation from the director sir. So there is no issue at all. Okay, so let's go to the again that will starting from spectroscopy method. So absorption spectrometry is a process, analytical process. So this particular thing is actually, if we check it out, so the absorption spectrometry means what is actually the meaning of this one. Absorption spectrometry is a technique that measures how much electromagnetic radiations. Yesterday I told about what is the electromagnetic radiation, and in the structure part you have already studied. So how much electromagnetic radiation is of a sample, that a sample observed, that how much electromagnetic radiation or sample observed, so that can be measured by this absorption spectrometry. The sample absorbs energy or photons, that means light particles or radiation fields. So this is what you say that absorption spectrometry. The process. Okay, so the process by which that technique, that principle based for this absorption spectrometry, the principle of absorption spectroscopy is based on that idea that material and sample absorbs a specific range of radiations. So let me tell one thing, that is particular this thing, that what is the work of this absorption spectrometry. This will absorb a specific amount. Suppose if we say that if we calculate, if we think one sponge, if we take one piece of a sponge and it will dip in the water, so that will absorb a quantity of water. After that it can't absorb that water again. So that is actually the thing like that. So this particular sample will absorb a particular amount of that wavelength radiations of that one. So that is the work of that absorption spectrometry. And this idea is coming out from that one. This absorption spectrum is dependent on the sample's atomic and molecular composition. Okay, So that how it will be happens means this depends upon that samples, what is the sample size, what is the that atomic structure of that particular sample, what are the molecular composition, suppose it is in carbon or nitrogen. So different base that components that is constituted particles with that sample will be associated. On the basis of that, that particular amount of radiation can be observed. So it is depending upon the particular atomic structure as well as that composition of that molecules. So on the basis of that, okay, am I audible clearly? That some students, they are raising the questions that I am not audible.
Yes, yes, sir. Yes.
Okay, so please, those who are unable to hear me properly, so just that is rejoin again, so that will be fine. Okay, thank you very much. So my end, from my end, it may be the everything is correct. So please check it out if anything problem in at your end. Okay, now the thing is that the absorption spectroscopy uses optical technique to analyze light that passes through a sample. Okay, I told you that this is a photon particles. See, when the one particular amount of light will enter to that, and suppose if we take the one that is sodium, if we take, I'll compare two things, two particular species. One is sodium, another is what is that if I'll take, okay, no, not sodium, cesium, cesium. If we take group one element, cesium, why I'm telling you that is cesium, you will understand that one. So cesium, and also that is your what is that chlorine, suppose I will say. So that is you know that in that photoelectric effect. So cesium, when the sunlight will fall on the cesium immediately releases the electrons. Due to the, actually that is the photoelectric effect, what you say. But chlorine, in case of these things will be take little bit time, little bit time. So you know that for the purification of water, so usually bleaching powder is used, and chlorine is the main component in that. So when the bleaching powder that will added the bleaching powder, actually this is antibiotic that properties are there in the bleaching powder. So when you put the bleaching powder into the water and it will keep in the sunlight, the that chlorine will be evaporated. So it will take some time. But in case of cesium, when sunlight will fall, then immediately it will leave the electrons. So thing is that these two things is depending upon that photon particles. So how they behave to the that sunlight, that depend upon their characteristics. So that is like that. Absorption spectroscopy is like that only, is that fact to analyze the light that passes through the sample. A beam of electromagnetic radiation passes through the sample. When a beam of electromagnetic radiation will passes through the sample, what will happen? In the photoelectrical effect, what will happen? That through the sample, and most of the radiation passes without losing intensity. So that means when the light will pass through that sample, the light is flow through an intensity, right? A particular intensity. When it will pass and will pass to the object, so it will directly pass through and without any losing any kind of, there is no issues with that intensity. Which intensity it passes through the sample, that passes on the same intensity. But few of the particles that they have changes their intensity. So however, at certain wavelength or the radiation intensity is reduced, that is called absorption, that is spectrometry. That is actually the principle of that one. So when that particular, when some very few that radiations when pass through the sample, they lose their intensity, the speed, the wavelength, the frequency, what you can say. So that will be blocked by that sample. So that how much amount of that is blocked, that will be calculated by this absorption spectrometry. So this is the principle. Okay, now it will come to the next slide. So where we can use this one? This is the clinical analysis of metal in biological fluid and tissues. We can use this absorption spectroscopy in this method. Pharmacology, then archaeology, manufacturing, mining, forensics. Okay, so if we see that in case of how, if we say that, if you ask me how it will that use in case of mining, see my ore. Actually, that Samna is just rejoin again. Some problem with your system, your side only. So that other students are clearly audible to me. Okay. So just a second. So okay, so this is the that if you ask me how it will be used in case of that is mining that ore, you know that mining or ore is a type of that in case of mining that ore is, so ore means multiple things associated with a particular matter. Suppose if you say the hematite iron ore, so that iron ore contains different oxides in the oxides forms or sulfide forms. What is that? The different components will be there, iron oxides will be there, right? So oxides, we have to remove that oxides. So that is in that segment we have to use the intensity, this particular absorption that is spectrometry. So where that intensity, so how that intensity of that particular radiation will be blocked, then we can calculate where the particular that is iron is specified in that area. So we can that extract and how much amount of iron is present over there. Okay, next if you go to that next thing, that will your okay. Now if we go to that, this is for example that ultraviolet and a visible absorption spectroscopy. This is another type of a spectroscopy. So as I told you that lots of type of spectroscopic systems there. So ultraviolet, UV and visible absorption spectroscopy. What is this actually? Or you know that UV and visible ray. So this is the wavelength. So on the basis of wavelength, you can, if you go to the structure pattern, you can see on the basis of wavelength that every region has a reason. So there is a which nanometer, that how much nanometer is there, that visible region, and how much nanometer is there for the the UV and all the things. So on the basis of that we can calculate. UV or visible spectroscopy is an analytical technique that measures the amount of a discrete wavelength. See, that is the terminology, discrete wavelength. You know that scattered discrete wavelength, how what is the amount of a discrete wavelength is there of UV or visible light that are observed by or transmitted through a sample in comparison to the reference or blank sample. Okay, so what is the theory based? If you see the picture of this particular that spectroscopy, you will see the picture. So what is that picture is telling? Light. So light comes with variety of wavelengths. As you know that light combination of 7 colors. So each color having that different type of wavelengths. So we have to bring one particular type of wavelength like PPL, plane polarized light. Okay, plane polarized light, if you see that one, so that is moving in a particular direction, all the beams will move in the particular direction like that. So if in this case we have to bring the light into a particular wavelength selector. So what will happen then? So the light will be only one type of wavelength light will be passed through that. Which wavelength that selector you have to use? Suppose I use 10 to the minus 14 nanometer wavelength, right? So that much wavelength, that light which is passed through that much wavelength, so that will only pass that one. Other remaining lights will be blocked. Okay, so that wavelength selector will be there. Then that particular light will pass through the sample. So what will happen? We have to check it out, as yesterday we have discussed. So analytical chemistry, that telling you that we have to make a proper plan, define what to do, how. So this is why you have to tell that the system is telling right now the sample, a particular sample is what type of wavelength light will be passed. You have to fix time to time variety of wavelength lights and pass through the sample. So then what will happen? Then that will be detected. So if it pass through that a particular sample and detect how much amount is discrete, means suppose wavelength is coming out to 10 to the power minus 14 nanometer, and now after when the passing that light through that sample, and we got 10 to the power 16 nanometer wavelength right now. So how much amount, discrete amount, that will be calculated by this particular that ultraviolet or visible absorption spectrometry method. Okay, what is the technique is also, means what is the, besides this, what is the principle? When the interaction between the incident radiation and the electron cloud in a chromophore, the results in an electronic transition involving the promotion of one or more of the outer cell and bonding electrons from the ground state into the higher energy state. What I told you exactly same thing. That this is how it will happen, that a particular that wavelength light you have to pass through the sample, then how much sample that particular radiation is observed, then what will the amount is released, what is the amount of that wavelength, what is the wavelength of that light particle now released. So you have to back to comparing to, and you have to check it out what is the difference between these two, then this is the process. Okay, now what will happen, how this is the principle. So principle of this ultraviolet and if you say that ultraviolet and visible absorption principle based on two facts. One is your light source. Okay, see that here is light is mentioned in that diagram. If you go to the diagram, the light source of light, we cannot use all source of lights. We cannot use all source of lights. So that is source of light is the most important factor here. As a light-based technique, it is a light-based technique. Without light, you cannot do this process. A steady source, sourceable to emit light across the wide range of wavelength is essential. See that what will happen? The light should be steady, okay, and wide range, number of range of that light should be that provided by that particular light source. Why I'm telling? Because we don't know that sample will absorb which length, which wavelength based light. We don't know. We have to do the facts. We have to do the experiment, and we have to record it. So that is the issue. So that's why maybe that a 10 to the power minus 8 nanometer light, wavelength light, it should not be passed. Maybe 10 to the power minus 14 nanometer light source should pass. So we have to record all this. Multiple wavelength light should be provided by the source, right? So that is the most important thing. Okay, now the thing is that a single xenon lamp is commonly used as a high intensity light source for both UV and visible rays. So widely you will say that it is xenon lamp used for this experiment, because xenon lamp gives the particular steady light source as well as that different wavelength source of lights. So that is xenon light is used particular for this source. Second thing is that xenon lamps are however associated with the higher costs and are less stable in comparison to tungsten and halogen lamps. So we can substitute that xenon lamps by using the tungsten and halogen lamps also. So be careful. That is what I yesterday told you, discussed with you all, that what you are doing, you have to choose the source, the definition, proper planning should be there. So then your experiment will be, as you know that it is that practical thing. So we can use that one accordingly. Okay. Next second point is that wavelength selection. Okay. This is important, another one, because as your slide, if you go to this slide, you'll see that so light source and wavelength selector. So these two sources are most important point in this case. So when we are coming to the wavelength selection, so certain wavelength of lights shoots that particular these things to the sample type of analyte for detection must be selected for sample examination for the broad wavelengths emitted by the light source. Available methods for, okay. Now the thing is that what will happen? So I told you that sample may absorb, may not absorb the light. So what type of a light source or which wavelength light should be absorbed by this sample, you have to think, right? You have to think on the basis of that, you have to choose that light source. Okay. Now the thing is that then what kind of methods will be monochromators. So that is a monochromator separates lights into the narrow band of wavelengths. So if the band of wavelength narrow band of band means gap, right? Size. This is the size that what you can say. Narrow band means very small size, very small thickness, very less thickness. That band will be there by using of the monochromo lights, monochromators. So that often the best, it is most often the best on the diffraction grating that can be rotated to choose incoming and reflecting angles to select the desired wavelength of light. So this is actually monochromators is the important method of source that can be used for the that is selection of lights particles. So absorption filters, another method is absorption filters. Absorption filters are commonly made of a color glass or plastic designed to absorb particular wavelength of light. Okay, this is another type of that a selector which used for a particular wavelength light. So that I told you that is the, so every that one particular wavelength of light should be observed by this one and it will pass to that. That is the way of this one. Okay. Second, next is the interference filters. So also called the dichroic filters. These commonly used filters are made of many layers of dielectric materials where interference occurs between the thin layer of materials. These filters can be used to eliminate undesirable wavelengths by the destructive interference, thus acting as the wavelength selectors. So this is the process by how that what type of different things we can use for the wavelength selectors. Next the slide is that okay, cutoff filters. So this is another also that a wavelength selector process method. Cutoff filters allow light either below or above or certain wavelength to pass through. These are commonly implemented using interference filters. Then band pass filters. This is another also. Band pass filters allow a range of wavelengths to pass through that can be implemented by combining short pass and long pass filters. These are the methods. These are the methods which can use as the source as the wave for the wavelength selectors. So this is the important things. Okay. Next, then application for this one that that your wavelength this is ultraviolet and that particular things application, different applications is there. Bacterial culturing, drug identification and a nucleic acid purity check, quantitations to quality control in the beverage industry and the chemical research. These are the areas where you can put where it can set this particular UV or visible spectrometry. So if we go to the next slide, it is infrared absorption spectroscopy. Infrared absorption, as you know, that it is a type of that is a particular wavelength that area is there. So wavelength range from 0.78 to 1000 micrometer. So this is the area which is known as the infrared absorption spectroscopy. So infrared absorption spectroscopy involves the absorption of infrared radiations depending on increasing the energy of variation or rotational associated with the covalent bond. See, yesterday also I was telling that one to people that actually spectroscopy nowadays has a very wide range of use. So where that what kind of bonds are there, whether these bonds are strong or weak, what kind of atoms are used, elements are used in this case, whether it is nitrogen, carbon, what kind of functional groups are present there. On the basis of that spectroscopy, that one graph will generated like this, what we observe here in the graph. So it will see that this is the graph which is made in the infrared spectrum. So that is how that depending upon increasing the energy of vibration or rotational associated with the covalent bond, provided it is covalent bond, provided that such an increase result in change in the dipole moment of the molecules. So okay, as you know that dipole moment is associated with the covalent bond. So what is the dipole moment is that change in dipole moments can be identified this way, infrared absorption spectroscopy. So if you go to the next slide, what is the principle that is associated with the IR spectroscopy? So IR spectroscopy detects frequencies of infrared light that are absorbed by a molecule. Molecules tend to observe these specific frequencies of light since they correspond to the frequency of the vibration of bonds in the molecules. I told you right now that thing is that this particular IR spectroscopy, when the infrared pass through that particular molecules, so specifically that your covalent compounds, so that will be how much that things is that corresponds molecules absorb the specific intensity of frequencies of light or wavelength of light. So on the basis of that, that a spectrometer will show the graph. So on the basis of that, we can calculate what are the particular atoms, or what are the particular molecules, or what are the behavior, what type of bonds are present in that particular compound. So this is most interesting and important also nowadays. Okay. So application of IR spectroscopy, infrared spectroscopy is widely used in industry as well as in the research. So identification of functional groups and structure elucidation. So I told you right now. So it is used for the identification of functional group. What are the functional group associated? What is the structure? How, which atom? If this the nitrogen bond is there, then what will happen? That graph will go till which condition? Everything is there. Identification of the substance. So this is also to find out what are the substances, that what is the substance that's present in that particular species, that compounds or molecules. Studying the progress of the reaction, how much reaction is progressed, it will within that it will complete within how many times, what are the moles will be formed, that everything. Detection of impurities, what are the impurities are present in this case, that will be detected by this IR spectroscopy. So this is an important method also for the in the case of spectroscopy. Okay, now another method is fluorophotometry. So this is an important method, fluorophotometry. Actually, this kind of things will be available in the spectroscopic system for the pH calculation. Okay, so pH calculation are the exchange of what that is a particular biological segments. So fluorophotometry is a non-invasive method of measuring vitreous concentrations. It can also be used to measure changes in case of epithelial permeability, corneal pH, and tear exchange. What are the principle associated with this one? The energy of photons of incident radiation observed and changes the observing species to the excited state. Certain chemical substances that after excitation can re-emit radiations. So re-emission of radiation can be immediately after the absorption, and is known as the fluorescence. If you have seen that fluorescent tubes, you have seen fluorescent lights. So this is the mechanism over there. This particular theory is applied over there. So once that anything will enter to that particular sample, then emission will be there. Further emission will be re-emitted. That is the double process. So that's why this is known as fluorescence. So practically proportional to the concentration of the fluorescent substance. The fluorescence intensity is practically proportional to the concentration of fluorescent substance. The measurement of the intensity of fluorescence serves useful analytical purposes, and the technique is known as fluorophotometry. Okay, so now the thing is that this is the principle based on that one, and a fluorophotometry has several applications. What are that? Diagnosis acute retrobubular neuritis. So this is one kind of a disease. So measuring the rate of a clearance of the fluorescent from the cornea and the anterior chamber. Then this is the optical method of use. Calculating blood retinal barrier permeability to fluorescence. So sometimes in that removal of that your laser operation of eyes and something is there, so using by the fluorescent, so it will be conducted. So this is a medical application is there. Next type of a spectroscopy is turbidimetry. So turbidimetry is a process that measures the loss of intensity of light transmitted through a solution containing fine particles. The name comes from the word turbidity. You see that picture is showing that one. So what will happen? The turbidity is a process that measures the loss of intensity of light. So when the light passes through an object or anything else, that will how much amount of intensity is lost by that when that how much amount of intensity of light is lost when that transmitted through that particular solution. So that because it contains some fine particles, so it will see that fine particles are there, suspension in the some fine particles are there. When the light pass through this one, so then some amount of light intention will be blocked by these fine particles. Then how much that radiations will be comes out, that is known as the, what is that? That is known as the turbidity. And the turbidity metric, the phenomenon is called the turbidity metric. So principle based on this one. The turbidity metric is based on the measurement of the loss of intensity of a transmitted light in an emulsion. Emulsion, you know, that types of, that is solution. Okay, so emulsion, that is due to scattering effect of a particle suspended on it. So that particular things, this what will happen when the light will pass through this particular solution, so that fine particles which were present over in that solution, that will absorb that light particle or block that, then the light intensity of light particle will be blocked. So how much amount of light particles is blocked, and how much amount of that particle is coming out, and how much particles now is coming outside after the blockage, so that will be calculated by this process. Okay, the application of that on microbiology. In case of microbiology study, monitor cell and the bacteria growth by measuring changes in media turbidity. So that can be also calculated. If that a particular in a solution, the bacterial growth will be there, so that when you pass the light, that as the bacteria, particles over there, they will absorb the intensity of light, and the remaining light will comes out, that will be calculated. Then on the basis of that one, we can calculate that what is the means how much, what is the size and mass of that one. So food manufacturing, in case of food manufacturing, monitor product quality and treatment process efficiency, especially the dairy and brewing industries. And in case of water quality, monitor water quality in drinking water, lakes, rivers, and the mangroves. Then another process is there where we can apply this this particular turbidity metric. So clinical chemistry determine the serum proteins not detectable with the classical clinical chemistry method. So which serum, actually that is serum protein cannot be detected by the classical clinical method. So that can be method by the turbidity method. That can be calculated. Okay. Next, if you go to the next slide, then actually nephelometry and a nephelometry and a turbidimetry, that simultaneously equal, somewhat in equal sense. Okay, somewhat in equal sense. There is no difference at all. But technically, there is a difference between nephelometry and a turbidimetry. Turbidimetry already we have discussed. That is that light particles which is blocked by the that particular light, intentional light particle will be blocked by the sample. Then some wavelength will be produced. But nephelometry is the type of that type of a turbidimetry. So an analytical method which is based upon the measurement of the intensity of light scattered by the suspension. That is emulsion. This is suspension of small particles is designated as the nephelometry. So that was the, in the turbidimetry, it was the, that is in case of nephelometry, it is suspension, that is there over that. What is that? That is okay, emulsion. That is emulsion. This is your suspension. Okay. Now see that two particular things are there. If you check it out, so in nephelometry comparison turbidimetry. So nephelometry, the light source is coming, passes through the lens, particular wavelength formed, sample cell passed, and a transmitted light detector. Okay. Now the in case of a turbidimetry, so this is that is a light source passed through the lens, then sample cell, it will be 90-degree detector. So this is the process, 90-degree detector. Okay. Now the thing is that if you come to the application part of the nephelometry, so pharmaceuticals, determining ions, impurities, and bacterial growth. In case of medicine industry, determining level of food plasma proteins such as antibodies. In case of analytical chemistry, measuring turbidity in solutions. In case of agriculture, food, testing ingredient solubility and determining the solubility points. So these are the applications of a nephelometry. So again, once again, these two methods having some equal things. One that is applicable for turbidimetry, applicable for the emulsion, and this is the nephelometry is applicable for the that is suspension. So you should be careful about that. Again, I am telling same thing, that when you are preparing for any kind of a test, you have to study the thing before doing any kind of experiment. You have to, what are the parameters, what are the SOP should be set for this process. what are the behavior of that particular objects, what are the sample, what kind of that is analytical method you have to use. So if it is spectroscopy, lots of type of spectroscopy methods are there which is suitable. So on the basis of that, you have to memorize all the technique principles and its applications. So on the basis of that, you can only that apply that one and it will be success. Or else that is several type of experiments you have to do. So this is not suitable for that because it is time consuming, loss of that is different cost effective, and also that lots of problem will be arises. So okay, now the thing is that another, that Raman spectroscopy is the another type of a spectroscopy. So you know that it's the named after our great scientist C.V. Raman. So by this method is named in the name of scientist C.V. Raman. So Raman spectroscopy is a non-destructive chemical analysis technique which provides detailed information about the chemical structure, phase, and polymorphy, crystallinity, and molecular interaction. You see that this method is non-destructive, means nothing will be damaged. What sample you will use, nothing will be damaged. But other sources, maybe sample will be damaged. Once that will be used, so it will be thrown away or destroyed, right? Or you have to means use particularly you have to keep in somewhere else in some segment in precaution with precautions. But Raman spectroscopy is the process where it is a non-destructive chemical analysis. So sample will remain like that. You can use in different process, in the different state you can use. So sample will be remain same. There are no changes in case of sample. And what we'll get in this case, we'll get that structure, chemical structure, what are the chemical compounds, what are the structure of that on phase and polymer. You see that I don't know that that suppose one compound in front of you, that is ethanoic acid. So what is the structure of ethanoic acid, you cannot say, because we are understanding the theory that ethanoic acid CH3COOH, right? So ethanoic acid. But thing is that if you go to the structure, if you analysis the structure of this one, so this one, you have to use any kind of technology, that is your spectroscopic technology. So Raman spectroscopy will explain without damaging that ethanoic acid. It can say it's what is its structure. Phase means it is solid, liquid, or gaseous, or plasma, whatever the polymorphy. Crystallinity, what is the it is crystalline, how the that is whether there is crystal, non-crystal, if crystal, what is the stoichiometric arrangement and all the things, and molecular interaction, what is the force of attraction over there. It depends upon the interaction of light with the chemical bonds within a material. So how it helps to find out, it is exactly Raman spectroscopy is just interaction with that particular bond, what is there, on the basis of that one it behaves. Okay, now the thing is that people see that below there is a graph picture. So that is the structure is given over there, right? One chemical compound is there, and on the basis of that Raman spectroscopy will get the graph. So by calculating this graph, we have to say what is the chemical compound is this, right? By calculating this graph, we have to say what is the chemical compound of this one. So Raman spectroscopy is a very good that principle, that spectroscopic method which can explain that without damaging the chemical chemical or sample. So what is the principle for this associated with this Raman spectroscopy? The principle behind Raman spectroscopy is that the monochromatic radiation is passed through the sample. So monochromatic radiation will be developed, will be produced by the Raman spectroscopy, which will pass through the sample, and such the radiation may get reflected, observed, and scattered. So may radiation will be reflected or absorbed or scattered. What is the behavior of that particular radiation, monochromatic radiation? That will depend upon the compound. So on the behavior of, on the basis of behavior of the compound, it may be reflected, may be absorbed, may be scattered. The scattered photons have a different frequency from the incident photons. So when the light particle will fall on that particular from the Raman spectroscopy, that monochromatic radiation, so that particular incident of the photons or that frequency is different than the, what is that, when it will be reflected, when it will be reflected, or when it will be observed, or when it will be scattered. from the as the vibration of the rotational property value. So on the basis of that, the graph will be generated, and on the basis of that, we can calculate what is the structure of that compound. Okay. Next, we'll go to the next slide. We'll see the application of Raman spectroscopy. Raman spectroscopy is a technique that can be used in many fields where destructive microscopy, chemical analysis, and imaging is required. So that means, see, this is the most important. If you want to destroy that particular sample, then other spectroscopy method you can use. If you don't want to destroy that particular samples, and also there is some limitations. Raman spectroscopy cannot help to that analyze or help to share all the informations. Okay, so you know that the structure, phase, and what is the chemical components are there that can be shared by the Raman spectroscopy. Not all. So thing is that here in this case, if you don't want to destroy that particular sample, so you can use this one. It can provide key information easily and quickly, whether the goal is quantitative or qualitative, whatever method. So that can be used by the Raman spectroscopy, that can be calculated by the application of the Raman spectroscopy. So where the area, the pharmaceutical and cosmetics, and it is important. That is why the pharmaceutical, you know that pharmaceutical companies, people that they are using some kind of they're testing on some viruses or bacteria or something else. So that means if sample will be destroyed, then what will happen? They may not have the much more sample. So that's why sample destruction method if there, so we cannot that sample non-destructive method will be there if you want to use the sample.
Skin is not visible.
Sorry?
Skin is not visible.
Okay, let me share another 1 second. Let me share 1 second. Is it visible right now?
Yes,
sir.
yes.
Okay, that's fine. So now the thing is that this Raman spectroscopy is that pharmacy. Okay, I was telling that one. If pharmaceutical company, they are using some. If we take the example of the coronavirus, right? So coronavirus is changing that time to time. mRNA is changed. So time to time. If we don't have sufficient of a sample, we cannot that use in. We want to preserve that sample. So on the basis of that, we can use that Raman spectroscopy. Hence, the sample will not destroy. So we can reuse that one. So it has a great implementation in case of pharmaceutical and other company where, or other industries where we can that use several times. Geology and mineral technology, semiconductors, life science, etc. So these are the areas where we can use the Raman spectroscopy, and we can find out that easily we can analyze the things, as it is a non-destructive that process. Non-destructive methods of that it will preserve the sample. It will not destroy the sample. So that's why this is most important area of that one, and particularly in the pharmaceutical industry, we use this one for the analysis of different chemical compounds and all the things. Okay. Now, so this is optical method is finished. So if you go to the slide number 12, so as per the initially we have slide number 12. Okay, just a second. Let me to slide number 12. So yesterday I told you the classification of different analytical techniques. So chemical method of analysis we have completed yesterday, and electrical method of analysis we have completed yesterday. Actually, these two methods already you have learned. So, but MCH-1, so having this optical method of analysis, and today I have finished right now I have finished optical method of analysis. Under the optical method of analysis, you guys learned different things. Let me to just inform you what techniques you have already see. That in optical method of analysis, that is yesterday I just have told you, that is emission spectroscopy methods, You have already learned yesterday. Absorption spectroscopy, today I have taught you. Ultraviolet and visible absorption spectroscopy, I told you. Infrared absorption spectroscopy, I told you. Fluorophotometry, I told you. Turbidimetry, I told you. Nephelometry, I told you. Raman spectroscopy, I told you. So these are the methods which is used under the optical methods of analysis. And you people have to understand that what is how the particular things is used in the particular segment. What are the emission spectroscopy, where you can use the emission spectroscopy, what are the major principle is associated with the sun, like that. Every method have some specific use, behavior, and all the things. So you people have to memorize these things, where you have to use this, and what is the particular work of these particular methods. So you have to memorize all the things, then you can use this in particular in the practical, when particularly you will do the practicals. Okay, so that is the thing that we have completed. Right now we'll go to the, okay, anyone has any questions about that particular the classification optical methods of analysis? Out of these 7, all are there in your syllabus. So do you have any questions? Okay. Now, the next method of this analytical chemistry, next method is a classification of nuclear methods. It names tells something. Nuclear methods means this is particular things. As you say that a nuclear chemistry or nuclear method will be associated. That means the radioactive elements may be presence of radioactive elements. So this particular method is used in that segment. So maybe it present of radioactive elements. Nuclear method means definitely somewhat in some cases radioactive decays may be present over there, right? So on the basis of that, we have to, this particular method is used for that. See that if that's why I'm telling you, a particular method has a role, a particular role. So like that, this is radioactive means classification of nuclear method means radioactive elements or radioactive decay may be present over there. So that's why this particular things will use wherever there is radioactive elements related things will be there. So you have to understand that nuclear method should be applied. So this nuclear method, particular things. So that's why when you're doing any kind of experiment or anything else, you have to understand whether there is any radioactive decay is there or radioactive elements are there, like rhodium, like polonium, like whatever may be the that radioactive elements may be present or not. Okay, so on the basis of that one, you have to use these particular techniques. Okay, so on what is that nuclear method? Some techniques which can provide analytical information based on the nuclear properties. Each of these properties or combination of them can best studied suitable by the analytical chemistry. Nuclear method can be grouped in the following methods: radiochemical methods, radiometric methods, isotopic dilution methods, activation analysis, Mossbure spectroscopy, this is the scientist name, nuclear magnetic resonance spectroscopy, and mass spectroscopy. These all methods, 7 methods are important. So let's go to the individual methods. Then radiochemical methods. Okay. So what is radiochemical methods? Radiochemical methods, you have to understand what is the method, what is exactly this is. Radioactivity can be detected and measured at extremely low intensities. So first thing, low intensity light or photon particles is essential. Okay, this is most important because as I told you, radioactive elements. So okay, I'll come to that point. Radiochemical method have a variety of applications. For example, in tracing the presence of a specific analyte when the sample is spiked with a small quantity of analyte in a radioactive form. I told you. In the concluded part, we understand that, so that sample should have radioactive form, means radioactive behavior. If any sample has, if you think the sample is coming from the Mars, If you think the sample is coming from the that is moon, it might be the radioactive elements, might be. No. So that's why you have to use that radioactive analysis. You have seen that in so many movies, Hollywood movies, you have seen that when that, not I'm telling about that, NASA or ISRO, when the that we don't the space satellite has not gone to that one, where human carried space satellite by the ISRO, but NASA, when that scientists will come, they will undergo a medical surveillance. What is that? Whether any kind of radioactive bacteria, radioactive elements, anything else, I don't know, that whether they are present over there in that with their body or something, they'll pass through a medical test. So that is the job, where that there is a radioactive traces are find out. So probability of that one, so we can use this kind of methods. So that means if you understand, if you think that is that particular sample has some radioactive behavior, or radioactive decay is present, or radioactive element is there, or radioactive nature is there, so that means this type of nuclear method you have to use. Okay. So that means it is depending upon our understanding whether that, okay, if you see that if radioactive elements is present, you use some another spectroscopic method, then there will be an accident. Definitely there will be an accident. So that's why you have to understand the particular things. Okay. Now principle, what is the principle? Radiometric analysis use a radioactive reagent to isolate the analyte from other sample components. See, this radiometric analysis is a particular type of a reagent. We have to understand what type of a reagent is there later on. So particular type of a reagent you have to use. That reagent will be that remove that other particles from the radioactive nature material. From that, it will remove the other particles and it will separate it out. Okay, so that is the process of radiometric analysis. The product active is directly proportional to the amount of analyte. Second, environmental liquid. So useful of the environmental radioassay to analyze small amounts of radioactive materials. So this environmental liquid scannellation analysis. So this is used to that small amount, where the small amount of radioactive elements are there or material is there, we can use this kind of method. Then gamma ray spectrometry. This is another important one. Gamma ray spectrometry is used. Use gamma rays emission spectra to identify the radioisotopes. So this is actually a traditional method. We are using also gamma ray spectrometry. So spectrometry, in that gamma ray will pass through that one to detect the radioactive element, whether the emission is there or not. If emission is there, that means radioactive elements will be that separated out. Okay. Next, what is the application of that? Tracing the presence of an analyte, environmental monitoring, nuclear power and waste management, radioisotopes, radiocarbon dating, food irradiation and radio tracers, nuclear medicine, radio level isotopes. These are the areas where you can apply this particular method. Okay. Now we'll come to the point. So radiometric methods. So second is that radiometric methods. Okay, radiometric methods. If you go to the radiometric methods, what is that? You see the pictures. See the pictures and try to understand what is there. Okay, now in radiometric method, a radioactive reagent is employed to separate the analyte completely from the bulk of the sample. The activity of the isolated material is then measured. Okay, now see the principle. The radiometric measuring principle is based on the attenuation of gamma radiation as it penetrates the materials. So gamma ray will pass through that one, and this type of picture will be, you can see. So on the basis of this picture analysis, where is the radioactive element is present, you have to find out. Then you have to separate it out. You have to separate it out. Where is the radioactive elements, and on the basis of that, you have to separate it out. Right. So this is the things of principle. Then we will go to the applications. Agriculture. In case of agriculture, measuring plant canopy temperature and estimate the plant water status. Roads, measuring road surface temperature to determine the icing conditions. Energy balance studies, measuring the temperature of a terrestrial surface like soil, vegetation, water, and snow. Weather satellites, radiometers are used in weather satellites to measure the thermal radiation of objects. Local weather predictions, radiometers provides thermodynamic profiling of atmospheric condition, including temperature, humidity, and a liquid profile. Nowadays, also this thing is used for the by the Met department for the forecasting of the that heat, cold, and all the things. Water resources, climate, foods, and droughts. Radiometers have application in these areas also. So these are the areas where you can apply the radiometric that okay, now the third is isotopic dilution method. So isotopic dilution method, what is the isotopic dilution method? See, isotope dilution is a radiochemical method for measuring the quantity and mass of an element in a substance. It is a technique that improves the accuracy and precision of chemical analysis. See, this is the what is the isotopic dilution. Now come to the see that explain isotopic dilution picture. See that sample isotope 1 and isotope 2 is there, right? Plus again added radioactive element. If you see this picture, you just see, then added radioactive. If I see that in isotope 1 is more, isotope 2 is less in case of sample. Now what will happen? I will do the reverse. Reverse means isotope 1 will be less, isotope means 2 will be more, added radioactive elements. Then what will happen? Then mixture will comes out isotope 1 and isotope 2 in equilibrium conditions. So what will happen in this case? Principle based on adding a substance or known quantity of radioisotopes of the elements to be measured and mixing with the stable isotopes of the elements. This is the procedure. This is the principle based on that. So that your radio isotopic dilution method is there. So application: studying the amino acids, studying phosphate fertilizers, quantifying selenium's body composition. These are the completely if you say that this is the agriculture application is much more in case of this that is isotopic dilution method. Okay, isotopic dilution method. Next, if you come to the point, next is activation analysis. So activation analysis, you have let me to explain one thing. In you have gone through the chemical kinetics or kinematics. So that is transformation of that is how the energy to transfer, then activation energy and all the things. Based on that, so this method is actually that method. Okay, activation analysis is a method for determining the concentration of trace elements in a sample. How much trace amount is there, what is the impurities is there, so what is the that other compounds are there. So on the basis of that we can calculate this particular thing. So principle is the basic principle of activation analysis is that irradiation by the penetrating radiation induce nuclear reaction in the nuclei of the analyte. So this is the method. If you see, I just enrolled this picture. So so this you just if you read this particular things, okay, so you'll understand that how the activation energy has the that role. Okay, so then if you go to that next, what is the application of the this activation that okay, what is the application of that activation analysis? So in forensic science, in medicine, in geology, in archaeology, so all these segments we can use the that activation analysis and we can do our that work. So Mosberer spectroscopy, this is the another type of a spectroscopy on the basis of that particular this is the scientist Mosberer, that German scientist is that. So this spectroscopy stands for the recoil-free emissions and absorption of gamma rays in solid. Because atom is in a solid, can vibrate, recoil-free, events occur if the recoil energy is less than the lowest quantized vibration mode. Okay, if the, so this is actually that whatever you know, that solid compound. So if solid state, the that atoms or whatever the molecules are tightly packed. Okay, the intermolecular force is high. So what will happen? The recoil of energy is very less in this case. Recoil of energy is very less. So in this case, as the recoil energy is less, so that will happen, the quantized vibration will be less also. So principle, what is the principle associated with this one? This means that nuclear resonance so is unobservable with the nuclei, free nuclei, because the shift in energy is too great and the emission and the absorption spectra have no significant overlap. If we analyze this source, if we analyze the picture, so you see that source and the observer, what happened there. So if in that 3 by 2 source is 3 by 2, then it will quantize splitting up there. Then what will that, this particular energy, this particular area is the activation energy. And also in this case, so what will happen, the Moselberg spectroscopy will analyze the things, and what is the velocity of the electricity light and all the speed, and also wavelength and frequency will be calculated. So this is the, and if you go to the application of this one, so biomedical applications are there, mineral technology is there, and a bio or inorganic chemistry, in that we can use this particular thing. Next, nuclear magnetic resonance spectroscopy, NMR. So this is actually another, NMR is in the medical segment. So NMR in the medical segment, in the company of medicine company, so it is usually use NMR spectroscopy. So nuclear magnetic resonance spectroscopy is a technique that studies molecular by recording how radio frequency electromagnetic radiation interacts with the nuclei of the molecules. So when the radio frequency that will pass, then the molecule, how does the molecule behaves to that radio frequency, so that will be recorded by these things. So NMR work is there. So that this is the, it is also known as the magnetic resonance spectroscopy, MRS. So both are two things. So principle, what is the principle there? The principle behind nuclear magnetic resonance is that when an external magnetic field is applied to many nuclei, an energy transfer is possible between the base energy and a higher energy level. So if you check it out, this particular picture, you can understand that. So if you check it out, that particular picture, and you can understand these things. So how that sample tube is there, where the sample tube is there, RF transmitter is there, detector is there, then absorption is there, then printer, what is the graph will be there, the magnetic controller is there, magnetic field is there, also that graph is there. This is the one type of that principle, based on that where we can use nuclear magnetic resonance. Okay, application of that, space, in the space research, that in the space, NMR is used to evaluate unconventional fossil fuels such as heavy oil and gas hydrated. Food science, NMR is used to analyze the constituents of olive oil and the other foods. Medicine, NMR is used in medicinal imaging techniques. So like that, I told you that in medicine, the NMR is there, such as magnetic resonance imaging, MRI. MRI, you have that all you customize, you know, that MRI. So in that MRI machine, MRI, when MRI will do, saying that particular this particular what is this particular nuclear spectroscopic or NMR is used. Okay. Next type of that, mass spectrometry. So what is mass spectrometry? Mass spectrometry is a technique that measures the mass to charge ratio of charged particles. So the results are presented as a mass spectrum, which is a plot of intensity as a function of mass to charge ratio. Okay, just a second. principle that mass spectroscopy is an analytical technique that separates ionized particles by their mass to charge ratio. So ionized particles means cationic and anionic particles. So mass and charge ratio, it can be separated out. The techniques involves ionizing molecules, only ionizing molecules, which will convert it into cation and anion, which means transferring them from a solution to gas. Okay, that means this is the mass spectroscopy. So this particular things is that but the sample will be taken, that sample will be vaporized, okay, and the detector will be there, oscillator, ions is there, magnet is there, magnetic field is there, detector is there. So all these things are this particular meter explain how the things will be organized in case of this. Okay, if we go to the application, classify unknown substance by molecular weight measurement and measures unknown compounds. What is the second that type of application of this one? Determine the structure and the chemical properties of the molecules. This is also that used in case of structural configuration. This your nuclear. Okay, that is just a second. The slide 12 reference to slide 12 is the nuclear method is completed. All the 7 processes. If anyone has any question, you can ask me over this one, or else I'll go to the next method.
Sir,
Yeah,
I have one question, sir. So
ask me.
in NMR spectroscopy, how we can identify the
Which spectroscopy?
animal?
Sorry, I didn't get you.
Oh, sir. Actually, sir, how we can identify the molecule where it's proton NMR? Then what is the behavior of the molecule in spectroscopy, and how can we identify the peaks in NMR?
See that actually that suppose I'm telling you. Suppose if you can take one molecule, right? You don't know what is the composition of that molecule. You don't know. You can take the molecule. So actually that one graphing that method is there. I'll tell you that we have to understand that the graph already. That suppose if it, that particular molecule contains, suppose I will take the methanol, right? CH3OH.
Okay.
So methanol, in the methanol, hydrogen bonding is there, OH bond is there. Also there is a
Yes, sir.
bond between carbon and oxygen. So
Yes,
when
sir.
we know that what is the means when the any spectroscopic study will be conducted. So we don't know that molecule, that particular substance contain methanol or not. We don't know. So when you put in that particular spectroscopic method, so what will happen? They'll detect one graph. One graph will be generated. So by understanding that graph, we have to further analyze the things that there is methanol or not. Okay, that component is present over there. So we have to understand that the graph. So graph technology will come down. Right now we are only understanding that think that what is the method are there and how we have to what type of method, what is the method basic principle, what is the basic principle, and which area it is means application is there. In the next session, means next class, we can means next unit, we can understand what is the main motto of that particular, how one spectroscopy give what type of a graph, which compound will give what type of a graph. Under that, by that, when you will do any kind of experiment, by analyzing, by calculating that graph, by comparing with that graph, you have to predict the products. What are the products are there?
Okay, sir.
Okay, right now only you are going to understand what are the types of methods. See that if I told you, if that is one any compound, suppose I told you any compound contain any kind of radioactive elements and will follow the wrong process. Got the point? So if we'll follow the wrong process, there will an accident. You know that what is the behavior of radioactive elements. So that means first thing we have to understand that from where that compound is came from. I am telling you the practical life. I am not telling about your what is that your lab. You know that what compound will be provided to you the lab. That is that also that particular see that if you understand one species is coming from other source, you don't know. Nobody knows from where it is coming down. When you analyze the archaeological facts, study the archaeological facts, you don't know what is there. So when you that, be careful about that one. That's why we are understanding the process, where we can use this process. What are the types? What are the pros and cons involved in this process? So then after right now we'll understand the different types of process. Later in the next phase we'll understand the graph. How, if the carbon is there, what is the range of the graph? If hydrogen bonding is there, you know that three types of bonds are called as hydrogen bonding. That is OH bond, NH bond, and FH bond. If that kind of bond is there, on the basis of that we can say that what type of bond is there on the analysis, by analysis of that graph. Without, unless if we not see the graph, we cannot say that what is the compound, right? Like that in one slide, if you see this slide, if you see, I told I am showing you one slide. Just a second. Here, see the Raman spectroscopy. This particular that slide in that one image is there, right? So that image is containing one above, that is a polymer. It's a polymer, and the particular things is a monomer, right? So this monomer having C double bond of carbonyl group is there, methyl group is there, oxygen, between oxygen is there, right? So these particular things will show this kind of a graph. So we have to analysis, we have to understand this particular species have this kind of graph. So already it is fixed. So on the association of this one, by transferring our knowledge, by collecting the facts, we can understand what is there, what type of a substance may be that. Okay, so after that we'll go for the, once you will conclude with one particular, suppose we'll conclude with a particular thing, then you will go for the another chemical test. That means this is not a conclusion. Once spectroscopy method detects something else, and you have to, there is some guessing points. Okay, this may be A, B, C, whatever. For A, you have to fix one process. For B, you have to fix one process. For C, you have to fix one process. So one process will be that give the positive result. Both other two processes will be give the negative result. So that's why on the basis of that you can calculate, and time to time you will overcome the situation, and at the end you will reach the. So it is the type of testing methods, right? It's the type of testing methods. Analytical chemistry, that is the most important thing. Now, okay, so classification of a thermal method of analysis. This is the reference to the slide number 12. This is the classification of thermal method of analysis. So thermal methods are classed into nearly a numbers of varieties, dozen of varieties. So we don't have, that is not essential to know all the varieties, but we have to, you have some selected types of varieties in your syllabus, that is TGA, DTG, DTA, DSC, and TET. Okay, that is thermogravimetric analysis, derivative thermogravimetric analysis, differential thermal analysis, differential scanning calorimetry, then thermometric enthalpy titration. These are the methods which is used in case of thermal method of analysis. So in case of thermal method of analysis, first we will go to the thermogravimetric analysis, TGA. So thermogravimetric analysis is a technique that measures the mass of a sample as it changes over time and temperature. So see, suppose you know that expansion and contraction process. This is the physical process, expansion and contraction. If we put an iron in case of temperature, heat, means sunlight, it will be expand. Though when it will be, that temperature will be low, it will be compressed. So that means same thing. If we apply same principle, so what will happen? So that mass of a sample as it changes over time and a temperature, when across you will pass the time, so mass will be decreased, because you don't know. That is, suppose if we put, suppose I'll put some water, right? Water, so molecule. So what will happen? If we keep molecule outside of that, you will keep open that container and keep outside, then time to time that particular mass will be decreases, because so time increases on the basis of temperature, air, and all the that environmental factors will be involved. Then mass of the water will be decreases. If you pour the water on the temperature, means gas or any that particular heat to the water, so then mass will be decreases. So time will increases, mass of the water will be decreases. So this happens. This is a natural process. Okay. So what happened here? So it is used to characterize material that gain or loss of mass due to the decomposition, oxidation, loss of volatile. Okay. So this so many things are there. If we say that hydrogen peroxide, if will there and it will mild, if will heat, so it will convert it in the what is that? If you provide the temperature, so what will happen? So temperature will provide, and time to time it will convert it in the water and oxygen. So this is that is both oxidation and reduction, that a disproportionation reaction, you can say. So these things happened. This is particular things when you give the as you provide the temperature, that decomposition method is there, right? So absolutely that will happen. Oxidation reduction will happen, and the mass will be decreases. All if you are well customized with this system. Okay. Now the thing is that, so Prince, what is the principle? So in thermocatalytic analysis, the sample is heated in a given environment like air, N2, CO2, helium, argon. So this is actually this the area where we can do the experiment at control rate. So control oxidation, you have seen that a control oxidation, control reduction. So controlled rate, because other particles should not be take part in this reaction. The change in the weight of the substance is recorded as the function of temperature and time. So time to time, as I told you, so time to time, so if temperature increases, then what will the substance will be decreases, because it evaporate, decomposition will be there. So time to time, when time will be changes from 1 minute to 2 minutes, 2 minutes to 3 minutes, then that temperature will be raised 60 to 70 degrees, 70 to 80 degrees. So like this, so time will be changed and the temperature will decreases or decreases, whatever the process. So that thing will be changes. So here temperature is increases, not decreases method. So temperature is increases method. If we check the graph, now we'll see that 100 degrees Celsius, then you will come to the 90, then 80, then what will happen? Then you have to understand what is the percentage there. So in case of 100 degrees Celsius, that is 100 degrees centigrade, so 12.44 percentage. So in case of your, it will come down to the 50, so it will around the 30.08 percentage. So that is why the decrease in things so happened due to on the basis of temperature in reference to the time. Okay. If you come to the point, that's the application of this one. Thermogravity analysis is a laboratory technique that measures a material mass change over time and the temperature. TGA is used to characterize materials for various applications, including environmental, food, pharmaceutical, and petrochemicals. These are the application of TGA. Okay. Now come to the point, DTGA. So it is a derivative of TGA. It is a derivative of TGA. The first derivative of TGA curve is known as DTGA. May be plotted to the determine inflection points useful for in the depth interpretation as well as differential thermal analysis. Or TGA can be used for materials characterization through analysis of the characterized decomposition pattern. So this is actually the first derivatives. Okay, so compare derivative means it is coming out from the TGA. DTGA is coming out from the TGA. The pattern will be analysis. The first derivative of the TGA curve may be plotted to determine inflection points useful for in-depth interpretation as well as differential thermal analysis. So see, if you see temperature and weight graph below, so you'll see that particular thing is changes and time to time it behaves. If will increase temperature, it will behave something. If will decrease temperature, it will behave something. So this is the derivatives of the TGA. What is the application? Can be used to determine a substance's changes in mass due to the decomposition, oxidation, evaporation, and the combustion. So this is the behavior. So application area, how the combustion, what is the amount of that a particular material has combust, or evaporation, what is the amount of that materials is taking part in the evaporation, and all the things will be calculated here. Next is the differential thermal analysis, DTA. So differential thermal analysis, DTA, is a technique used in analytical chemistry to identify and analyze the chemical composition of the substances. It involves observing the thermal behavior of a sample as it is heated. The principle based on the differential thermal analysis is a thermal analysis technique that measures the temperature difference between a substance and a reference material. The substances are subject to the controlled temperature program. If you see, if you understand this diagram, graph is there's a picture is there, difference between DSC and a DTA principle. So DSC will go to the calorimeter right now. So differential that a thermal analysis, this the right hand side picture is there. So differential thermal analysis, temperature difference. So sample and a reference electrode. So what is the difference of temperature between these two? So on the basis of that, we can calculate. Application used to detect physical change in a material such as mass loss, thermal decomposition, and phase changes. Then another in the food industry, DTA is used to characterize phase transition in the food such as crystallization, melting, glass transition, and conformational changes. Okay. DTA is also used in the many fields including pharmaceuticals and food industries, cement industries, mineral industries, and environmental studies, archaeological survey, and all the things. Next, if we come to the point, so this is differential scanning calorimetry. What picture is over there? So differential scanning calorimetry, DSC. Differential scanning calorimetry is a technique that measures the heat flow rate to or from a sample as it is subjected to the control temperature program. See that the temperature may be absorbed, may be emitted. So that is depending upon the material. So as it is a highly sensitive technique that studies the thermotrophic properties of biological macromolecules and extracts. So this is a sensitive issue. So that why it is particular used. Differential scanning calorimetry is a technique that measures the heat produced or absorbed during the material transformation. It compares the sample of an inert in reference and measures the difference in heat required to increase the temperature of the sample and reference. So these are the technique, method, and principle which are applicable. So application, biopharmaceuticals. DSC is often used in the biopharmaceutical settings to characterize and engineer drug products. It has been used in the pharmaceutical field for excipients studies and DNA drugs. Biochemistry. DSC is often used to study biochemical reactions, which are when a molecule transition from one conformation to another. It can also determine the thermal transition temperatures of samples in solution, solid, and mixed phase. Safety screening. DSC can be used an initial safety screening tool. In this mode, the sample is placed in a non-reactive crucible and can be withstand pressures. So these are the applications of this one. Then come to the thermometric enthalpy titration. This is an important method. This is used of thermometer as in the titration. Thermometer is used. So thermometric titration is an instrumental titration technique where endpoints are located accurately. So the endpoints are located accurately. This is the most important. It is utilized the enthalpy change of a chemical reaction to locate the endpoint. This technique is an adiabatic system. You know the adiabatic, isobaric system. So adiabatic system, meaning no heat transfer. So that means no heat transfer means from system to that surrounding or surrounding system is not possible. Means you can say that it is an thermoplex, thermometers. Thermoplex is there. That type of a system is there that yields a product of a temperature against the volume of the titrant. Principle associated with the TET is based on the principle of enthalpy change. Each chemical reaction is associated with a change in enthalpy, which in turn causes a temperature change. During a titration, analyte and a titrant react either exothermically or increase in temperature, or endothermically, so decrease in temperature. So this is the picture where you know that B road is there and hydrochloric acid is there. So if below that thermometer is placed, polystyrene cup is there. So and on the basis of that, so we have to calculate. But the application of this one, determining acid and base number. So acid and base number, whether it's a monobasic, dibasic, tribasic, or that is on the basis of that we can calculate. TET can be used to determine the acid number and base number of phosphate, sulfate, ammonium content in the fertilizer content, the sodium content, and various. See, this is very specific, that phosphate in acidic or sulfate in acidic or ammonium content like this. So you have to very specify these things. We specified these things. You have to use in a specific direction. Analyzing acid mixture. TET can be used to analyze acid mixtures. Complexions, precipitations, redox, and neutralization. TET can be used in these reaction also. Titrating gases. TET can be used to titrate gases against other gases without a liquid phase. This is an interesting one. So titrating liquid solution. TET can be used to titrate liquid solution with gaseous reagent. These two are interesting things which can be TET can be helped out. So these are the that method which is that we have explained this one. So thermal thermal methods of analysis. So we have discussed all 5 methods. If you have any questions, you can ask me. Neither we'll go to the next slides, next things, next process. Okay. Okay. Now refer to the slide number 12, and this is another method, that is classification of separation methods. See that actually this here are 2 types of methods are there. One is classical method, second is modern method. Classical method means that you have to understand that what is classical method. You know, hand picking, magnetization. Suppose some that is sand and iron mixture is there. We have to that separate the iron. So we have to use the magnets over there, and magnet will be attract the iron. Then sand will be separated out. This is I think this is what you say the classical method. Crystallizes. Suppose filtration. So this is the hand picking. So that is roasting. These are all are the classical methods. Always it was there, and now it is there. All are that is customized with this all system you have studied in the last degrees and all the things. So no need to explain these things. We have to go to the modern techniques. Okay. So modern techniques is the part of this one. So that means so that a classical method like precipitation, distillation, sublimation, formation of complex, these are the classical methods. It is before there, right now it is out there, and in the future it will be there. But modern technology, modern methods are there: chromatography, solvent extraction, ion exchange program, and electrophoresis. These 4 methods are there in your syllabus, which is known as the modern methods, and all are having the very important in your that practical life of studies. Okay. Next, if you come to the point, so there is a note that what I told you that is there. You are all aware about that classical methods, and only the modern methods will be defined here briefly, and in the course MCH-002 will be learn these methods in details. So in MCH-002 you learn these methods very particularly, very detailed structure. But classical methods, as I told you already, you have you already know these things: distillation, the fractional distillation, that magnetic separation, okay, roasting, leaching, all the things you already studied in your last classes. So that does not that we don't have intention to teach you again, but we have to come to the modern techniques only. As one student asked that what is this, how can I determine that molecules and all the things I told you. So these things today in this unit we have to understand what are the that methods and techniques are there, and where you have to use that, or what are the principles are there. We'll study in terms of MCH-002 in your program. The chromatography is the method that modern method, modern technology. So where the chromatography is a laboratory techniques that separates the components of a mixture. So chromatography is used to separate the components from a mixer. It is a physical method that separates components by distributing them between two phases. Suppose that one phase is stationary, other phase is mobile. So in this case, what will happen? We have to choose a particular things. So if you go to the next slide, you will see that chromatography process. So strip of a filter paper I have taken, right? So suppose that you can see that suppose you have to that sand and mud water is there. Okay, sorry, sand water is there. Sand and water, that solution is there. Mixer is there. It is a heterogeneous mixer. We have to, one is mobile, that sand is that stationary, and that water is mobile. So that means it will pour that one in the filter paper, so it will pass, water will be filtered and the sand will be remain over there. So this is the chromatography, one type of a chromatography process. This is actually, this is not the, I try to explain the things in the right way where you can understand the proper things, that what is stationary, what is mobile. So here, due to the mobile nature of the water, it passes through that particular filter paper, but as the stationary nature of that sand, it is remain on that particular that is filter paper. So separated out is there, but actually that lots of things are there in chromatography. So okay, so thing is that you will see here the suitable observant is should be there. Suppose you have that you have iron and water, so you have to separate it out. How you'll put the sponge over there or magnet over there? So magnet will carry that iron piece, a sponge will catch that water particles, that mobile water particles. It will comes to the, it's soaked by the that absorbed by the sponge, and the remain iron will be there. This is a type of a chromatography. So this simple that example I told you, but actually if you go to that in the particular things, you'll understand that chromatography is a separation technique that separates mixtures of chemicals into its components. It is based on of the principle of selectivity absorption. This is most important. Selectivity absorption means one particular means mobile, which is mobile, that suppose if two chemicals are there. Okay, so but that means absorbent should be, suppose if you see that oil and water, that is there, we can use the particular one absorbent, that is which can absorb the particular things, maybe water, maybe oil, whatever be there, so we can use that one. So that is selectivity process. It is a selectivity process. That selectivity absorption, which is separate, which is the separation of molecules in a mixer from each other while moving with the help of the mobile phase. Okay, this is the techniques, and this is the picture what I show you. So see, that is a strip of filter papers, and we dip that one filter papers into that particular strip of dip into the water, and again that water rise of taking dyes along with it. Then what will happen? Different colored spots of dyes separated from the black ink. Okay, this is the separated things. Okay, next, what will happen? Application, medical and environmental application in that segments. You can apply this one: food analysis, pharmaceutical, toxicology, and quality testing. Okay, next we will come to the solvent extraction method. So solvent extraction is a technique for separating a substance from a mixer by dissolving it in another solvent. Okay, to here that that is a mixer by dissolving with another solvent. What will happen? That it is also known as the leaching of a solid liquid extraction. Okay, so principle, what is the principle associated with it? When an organic compound, whether solid or liquid, is present as a solution in the water, so it can be recovered from the solution by shaking the solution with a suitable organic solvent. Right, so if any organic that compound is there, so if you put that with water, so we can add a particular solvent which can absorb that one particular organic materials and organic components, and it will be separated out. So this is very selective process. The organic solvent select should be such that in two process we can select the organic solvent. First one, the given solid must be much more soluble in the organic solvent than in water. Otherwise, water and organic solvent should not be miscible to each other. Two things are these two things should be there. If this is there, so then you can apply the solvent extraction process. What is the application of this one? Centrifugation. This technique isolate the extraction of solvent by sedimentation from the for the injections into the gas chromatography. Second, ionic liquid. These are used as alternative to the traditional volatile organic solvents because of their unique properties and good solubility for many different materials. Then subcritical water extraction. This technique use water as an extraction solvent. Then anhydrous sodium sulfate. So the agent removes water from the organic solvent and their extracts from the organic synthesis and instrumental analysis. These are the use of this that is what is solvent extraction. Next, another method is their ionic exchange. So this is an important method. This is cationic and anionic that separation method. So on that, particularly in the redox reaction, we can use this one. ओके सॉरी किसने लिखा एक हिंदी में ओके हिंदी में so it is not okay. So the thing is that in ion exchange, it is a stoichiometric process in which a solid material known as ion exchanger, when comes in contact with an electrolyte solution, takes either positive or negative ions. So that electrolyte solution means, you know, that electrolyte solution is separated out in the cationic and anionic part. So here ion exchange means solid will exchange by another one. Cationic part will be exchanged with another one, or anionic part will be exchanged with another one. So, and with an electrolyte solution takes either positive or negative ions and release the ions of like change or like charge. You can say that is stoichiometric like charge to the solution. The solid material having cations as exchangeable ions are known as the cation exchangers, and having anion as exchangeable ions are known as the anionic exchanger. What are the principle? Ion exchange resins are insoluble granules substance. You see that actually this thing is that if we'll use the filter, okay. So I can share one thing. So saline water. So nowadays the drinking water, fresh water is means time to time we are not getting fresh water, and so within few years of few years you will not get the sufficient amount of drinking water. So it is the best policy to exchange that your saline water means sea water can be converted to the saline drinking water also. So now so many countries are using these things like your UAE and all the countries. But thing is that we have to come across this particular resin. We have to develop like a calendar that used in case of your water purifier. So in that water purifier, that resin should be that absorb that salines as in cationic form and anionic form, and water will be released. So these are the techniques you can use in this case. So ion exchange resins are insoluble granule substance which have in their molecular substances structure acid or basic radicals, and that can be exchanged. The positive or negative ion fixed on these radicals are replaced by ions of the same sign in solution in the liquid in contact with them. The ion exchange is complete without derivation of the solubilizations. So changing the total number of ions in the liquid before the exchange. Okay, these are the methods. You can see that you can observe the pictures. Now you can analyze the things. You can how it is ion exchange programs. Positively charged ion proteins binds to the negative charge bits, and negative charge protein flows through. Okay, so this is the ion exchange process. Now application. Ion exchange chromatography, or technique used for water purification, especially for converting hard water into the soft water. It can also detect or inorganic salts. Then what is the another application? Ion exchange treatment of drinking water. Ion exchange techniques are used to purify drinking water, wastewater, and the industrial effluents. So column chromatography, a technique for separating and purifying complex mixture of organic compounds. It can be used to separate a wide range of compounds, including small molecules, proteins, and nucleic acids. Catalysis, ion exchange reagents are widely used in catalysis, particularly for hydration and condensation reactions that proceeds rapidly at low temperature. Okay. Next, if you go to the electrophoresis, actually this is that electric field. When the application electrophoresis means charge particles, transformation of charge particles, you can say. In electrophoresis, an electric current is passed through the molecules to move them so they can separated with a gel. A movement of particles under the effective of electric current field is known as the electrophoresis. So principle, the fundamental principle of that a charge, when the electric current will be there, the two types of ions will there, cation will hold the anion and anion will hold the cation. So this is the principle. The fundamental principle of electrophoresis is the existence of the charge separation between the surface of the particles and the fluid immediately surrounding it, and an applied electric field acts as a resulting charge density, causing the particles to migrate and the fluid around the particles to flow. So this picture is help you to understand what is the electrophoresis process. I told you, in the cationic part, it means cathode is there, so that will be hold by the that positive charge will move towards the cathode, and if anode is there, the negative charge will pass towards that. So application, what is the application of this electrophoresis? DNA analysis. Electrophoresis is used to separate DNA fragments of a different size. This can help identify the DNA damage or mutations, analyze DNA pattern, or identify the genetic variations. DNA fingerprinting. Electrophoresis is used to separate DNA fragments for DNA fingerprinting to investigate crime scenes. DNA profiling. Electrophoresis is used to DNA profiling for taxonomy studies to distinguish different species. Okay, these are the things. So, and also that is protein analysis. Electrophoresis is used to separate the different proteins or isomers of the same protein into the separate brands. Antibiotics. Electrophoresis is used to separate the antibodies in the antibiotic form from any impurities. These processes also enables researchers to determine the concentration of the antibiotic, making dose more accurate. Then forensic science. Electrophoresis is used to study structure and function of the protein, RNA, and DNA. It is also used for analysis of drug of abuse and analyzing explosive components and reduces. So these are the things. We have finished that is still that what is that, all the slides, and now the process will be there. So if you come to the point, so we have, this is your syllabus. So till the last part will contain, that is, just a second. So okay, criteria for one part is there, criteria for evaluating the utility of the analytical techniques. Okay, how to do, what is the process, sampling, dissolution the sample, what is that the process is there, measurement, how will measure these things, and another part is emerging needs and recent trends. Okay, this is the area where you can use. I told you that already this part was discussed. So thing is that we can use this analytical chemistry in various segments. Yes, Piyush is there. Sir, can you share this PDF? Okay, I'll share that in one. Sir, I'll finish that unit. Once unit will be finished, you will get all the things. Okay, that is the everything. I just promise you that you have to share. So explain in Hindi. Actually, this things is very difficult, but I'll let me to see that one. sir, how much length of answer should be assignment question of 5 marks? See, that is depending upon the situation. 5 marks length means if you ask that's a 5 marks question and if you write down, see that question will come means suppose like this, what are the different techniques are used in case of your that nuclear method of separations analysis. So you have to explain all the things. That is 5 marks question. One question came, but under the nuclear that method of analysis, we have studied 5 6 methods. So you have to explain all the methods. That is the most important things. Okay, anyone has any question? What assignment has to be submitted? Where can I find it? Okay, so you consult with your study center. Actually, this is the all India class. So you people have different study centers. You just consult with your study center. You people have that actually the issue of that is something so like that regional language or something Hindi like that. So you know that this is all India class. So you have to understand my problem. I can't speak in that Hindi or particular any kind of language. Okay, so anyone has any questions regarding today's class? All of you understand? All of you got the proper that things?
Yes, sir.
Okay, that's good.
Yes, sir.
Good, very good. If anyone has any issues, you can share with me chat or you can ask tell me over this live call. So I try to sort it out. Okay, I think there is no issue right now. So we have to stop the class today. For today, it's going to be 6:50. So that is tomorrow, same time, 5 to 7 will be there. So tomorrow we'll finish the unit 1. Okay. So after that, we'll discuss some things. Then we'll see that what to do. Okay. Thank you very much.
Thank you, sir.
Okay.